సాఫ్ట్ లీడ్ అనగలరు? ఒక ఓల్డ్ స్కూల్ బ్రాట్వా అండర్ బాస్ డ్యామేజ్ అయిన ఏటీఎఫ్ వైర్ ట్యాప్ లో నోబి చోక్ అన్న మాట విని ఈ స్టెప్ తీసుకోవడం. అటాక్ చేసే ముందు ఎవరైనా మాట్లాడుకుంటారా? ఎప్పుడు మాట్లాడుకుంటారు, కానీ నమ్మ
Sino? Eh? Onu पकड़
Good evening, everyone. I welcome all on the behalf of Dr. Anmol Gautam, convener of this organized FDP. I think we have Mr. Japesh Chandra with us. Sir, have you joined?
Yeah, good evening.
Good evening, sir. I'll introduce you on behalf of Dr. Anmol Gautam. We welcome Mr. Japesh Chandra. He has done his bachelor and master's in mechanical engineering from Punjab Technical University, Kapurthala. He has more than 20 years of experience in mechanical industry. Presently, he is working as Chief Manager Corporate at International Tractor Limited, Sonalika at Hoshiarpur. He earned PMP certification from the PMI Institute in Project Management. Previously, he worked at Birla Group and Modern Automotive. We welcome you, sir. You may start your session.
Thank you. I'm going to share my screen.
Sure, sir, sure.
Whether my screen is visible to everyone?
Yes, sir, it's visible.
Okay, fine. Thanks for giving me this opportunity to express my experience as well as my knowledge, what I have earned over the period of 25 years in the industry. As the topic says that we have to focus on the auto. So I'm just projecting my slide to give an overview to all my audience that how big is the market of automotive, particularly talking about the car sections in this slide. When we talk about the market where we are all going in the morning and doing some job, putting some energy, coming back, and that aspect of our efforts is creating some GDP for the nation. So looking at this, the purpose of this overview is only to understand that there is a lot of opportunities. There are a lot of market entrants are available globally. We need only to understand how we can give our best to improve the running scenarios, the running materials, running methodologies, running challenges of current uh, processes. So if you see, the Tesla is making more money uh, in the world in the scenario of cars. So this is what about the opportunity and the market. Now, if you see just one another overview, I just want to how the market is changing based on the material. In 2023, we have around 59 million cars sold globally, and now there is a the EV vehicles, EV cars. Look at the projected values that it is going to be around 16.2% increase in the EV vehicles. It means it is having a huge opportunity for the chemical engineers, for process engineers, for electronic engineers, for physics experts, for chemistry experts, and process experts. Computers, because that is the core segments now every industry, whether it is a car making, whether it is any industry. So to give you just a small overview that how the market is shifting toward new segments where the opportunities are more. Only we need to understand what market demands from us, and we have to put focus. The more onus lies on our faculties who are into the field of computer and chemistry, because in coming years or coming decades we are committed to deload whatever the pollution or the environmental aspects we are facing now, and we are heading toward the sustainable development. So these areas or these streams, these fields are going to flourish. uh, to just to understand, there is one more slide I just want to project, that although there was a decrease in the year 2023 in the industry with minus 1.77%, but the positive factor, if you see the patents, how many patents are coming, means a new brigade, our new engineers, our new scientists, the industry experts, they are putting more focus on the innovations. How many innovations are coming? It's important for an industry to grow, because this will create more options, more talented people will come into the industry and they give their inputs. All this is happening because we are putting focus on improvement of traditional materials. Earlier, we were focused on the traditional. So this was starting as uh, Mr. Amol explained that I'm from the industry. So I give you a brief overview of my organization. I'm working in Sonalika International Tractors Limited. This is world's #1 tractor manufacturing plant. There are some factors on which we say that we are #1. So the founder of this tractor industry, Sonalika, is Lakshman Das Mittal, who started this industry in 1966. You look at that time, the material was process, material, and the logistics. All these things were so limited that the first tractor parts, the material being transported on auto rickshaws at that point of time. Later on, they put efforts, and now they have built a empire where almost 10,000 plus employees are working in one roof. Why we call it a #1 in tractor? Because it is an integrated factory where all operations, whether it is assembly, whether it is machining, whether it is testing, raw material like casting manufacturing is in-house and integrated through conveyorized robotic systems. We have presence in 150 countries, and we are manufacturing tractor from 20 to 120 HP range with 70 plus implements for the world for the farmers. So this is situated in Hoshiarpur, which is a core city of Punjab. So why we are Number one, because we export brand from India. Number one brand, because we have almost 34.4 market share, and we are supplying tractor to Hungary, Germany, Finland, Portugal, and so many other countries. Heavy duty customized crop solutions. We are providing all implements with farmer to increase their yield. We have tractor manufacturing plant in Punjab, Hoshiarpur, and also some in assembly plants across the world in Algeria, Brazil, Cameroon, Turkey, where we are assembling the sending from here, and we are meeting the demand in the respective region. Sonalika is also actively CRS activities. They are supporting the society, also financing the business partners and helping them to achieve their business potentials. And the list is quite long. So let's back to the topic. I'm just giving the brief history of the automobile back to 18th century, where the German and French started this automobile. The first automobile they perfectioned, they practiced, and later on the Americans quickly take over the industry. In the first half of 20th century, the big giants Ford, Chrysler, and General Motor, they pool their resources together and they become automotive industry leaders in 1920. All this happened because they and their team put efforts and innovate different materials, different techniques, different synthesis processes to minimize the wastage and improve the quality of the product. Thereby, they become the leader of the world, and then they also contributed a lot for the military equipments in the World War II. We always says that there are always two parts of a coin, two sides of a coin. Like although the world was not a favorable situation, yet it gave an opportunity for Europe and Japan to boost through automotive uh, vehicle automotive uh, segments. And later on, the Japan become the leader in 1980 in automakers. So I'm just showing two pictures. One is the way back in some around 90th century, and then there's a new modern vehicle which is a future vehicle also. So what is the difference? We can understand that the materials is making its difference in the appearance. You can anybody can understand that if there has been any change, it is only because of the change in the material and their properties. The different material, new materials who can withstand more forces, more stress, more machining operations being developed over the period, and they give a new look to the vehicles, and it opens a different outlets for the young generations, scientists, researchers to come and do the research and make this world more beautiful. So the early material which we were focusing on only wood, metal and leather, the material these were mainly used at the early stage. The wood framework, the steel frame was used for making body in white, means the shell of the cars, leather for the interior. Then some natural resources they were using, like material which was in abundant in the localized region. Before globalization, the items or the material which was available in that particular region being used. Like in today's scenario, we are more concerned about vocal for local slogan from the government, that we should put more focus on our local products on a concern, and that is one reason that we are bringing all the industry in India. So we have a better future, better production systems and better infrastructure. Same is the production techniques. Earlier, the production techniques, how they are producing. Look at the cryogenic engines. Nobody was sharing their technology, that how the cold fuel they are making it so cold that it's densifying, increasing the density so that they can store that huge amount of fuel in a small space, and it can run for hours, more than imagination. So those production techniques, chemical engineering has put their efforts, mechanical engineering put have efforts, the physics has also played a very vital role in all these developments of material. We will discuss a few new materials which are just evolving in the market. Same was the case with the design. So these was the early understanding of the material we were using. So just to give you a one small overview of the wheel. Look at the initial stage, how we were using a wooden plank, just a wooden disc at the very beginning. And now we are able to make a carbon fiber wheel which can take a load of 535 metric tons. Anatova AN 225. This is the Ukrainian heaviest payload aeroplane. It has its own weight, 200 tons, and it has a capacity to carry around 225, 235 metric tons. That is almost 50 cars. So this all credit goes to the changed material, the new innovation materials, the new processes, how they have synthesized the rubber and how they have synthesized the carbon with the fibers to make them so solid, so strong that they can withstand the shock as well as they can endure the tremendous force, tremendous load on their back. Why we were discussing all this thing? Because the necessity for these materials, we have you all must be aware about that. There was a series of global summits taken place. 1972 UN Stockholm, where we were more concerned about the environment. 1992 Rio Earth 2015 Paris Summit, where we are more concerned to save our earth because of the amount of load we have put on the environment on account of pollution, the landfills, the air pollution, the water pollution. It is becoming a very horrible to live on the earth, and all this can be achieved by innovating new materials. Those materials should be sustainable, should have low carbon footprints, and should be manufactured. The more important thing is should be manufactured in the industry with low cost. This will achieve us fuel economy, cost, recycling, and reduction in emission. So how it is possible? We must use lightweight alloys, composites, advanced materials, smart materials, which we will discuss in the following slides. So taking another example, that how the steel we were using, that counting to the weight of a vehicle, a particularly small vehicle, just we want to understand the contribution of different segments of a body in white, means the shell of the car. The closures has 6% weight, hardware 7%, interior 11%, electrical 4%, fluid 5%, power unit 18%, suspension 12%, fuel exhaust 7%, steering, brakes 3%, wheel tires 7%, BW body in white 20%. So why I am showing this pie chart? To give a overview for our chemical engineers, our electrical, electronic, computer engineers, our mechanical engineers, the physics experts, that everybody has to put effort in the material stream to reduce respective carbon footprints. A power unit, let's say a battery, which is increasing more and more, uh, new entrants are coming in this field because we are more leaning toward the electric vehicles. Fuel also going to change. Today we are focusing on diesel or petrol. Tomorrow there may be a biofuel or something other which can reduce the carbon footprint. So all these are the materials which are changing, and when they are changing, they are creating a different environment. It has their own merits and demerits. That is, we need to understand how we have to choose. But the point is, the second slide which I have shown, that our focus from the industry side, because I'm in the industry, is more to develop people who are more research oriented, who are more with an attitude, with an uh, zeal to learn new things, so that once they learn new things, they practice new things, they will have that power, they will have that courage to say no to the old thing, the traditional practices. Once you make your mind, then only you can make a change in the system. Otherwise, the traditional materials will keep on using. Still, there are material which we are using, and over the few years you will see those material getting extinct. Look at the brass headlights. You might have seen those halogen big headlights made of a brass. Now, no way, we are unable to see those halogen bulbs there, halogen tubes. Everything changed with the LED lights, which is more smooth, less power consumption, and long lasting. So things are changing. So the main focus is sustainability in automotive. The material, we should find those material which are more sustainable, which will help us sustain uh, in the automotive, more innovative materials in the automotive sector, automotive industries. I will show you some videos, some pictures, how we have uh, changed the the scenario, how material has evolved that can withstand high temperatures, and they are useful, or they are creating less pollution in the whole system. When we are reducing weight, altogether we are reducing the load of the supply chain. Suppose if a product of, if a car, let's say of 1 ton, we have to transport it from one position to another, there would be some amount of carbon footprint it is leaving behind. If same car with same capacity for, let's say, 5 passengers and same durability, but of low weight of 900 kg weight or 800 kg weight, every 10 or every 9 vehicles will spare one vehicle. The footprints of transfer, footprints of manufacturing is going to reduce. So that is, we are heading for sustainable development goals. And that is only possible if we are putting more efforts for developing new materials, for doing research. It is not a one-day job. It will take time. You will develop a component, then you have to study the process, you have to check it, you have to do some trials, you have to send it in the field. Once you are sure, then only you can send it in the auto market. Till that time, everybody's lab is involved, the technician is involved, the scientist is involved, the researcher is involved, the engineers is involved. So importance of sustainable material. Sustainable material in automotive manufacturing is essential for reducing carbon footprints that we discussed. These materials are not helping in resource conservation, but also improve the recyclability of the vehicles at the end of their life cycle, promoting the circular economy. That means whatever you are producing, if we are using plastic components, those plastic components can be recycled and a new component can be made of that. So that will help us drive a new economy, a new entrant, a new industry. So I'm just taking you through one casting industry which is blooming nowadays. So this one slide I have projected. This is a global market data which have been captured in 2019 and projected growth till 2026. So this is about the LFC process. Some of uh, the student or some of the experts on the panel here must be aware of the LFC process and green sand casting. Green sand casting process is a process which helps us uh, to cast the components, gray cast iron or malleable SG cast iron. And LFC is a lost form casting process. These are the difference of the process which I'm just trying to explain here. In casting industry, casting is what we are manufacturing, and then it becomes the housing for another components. Like you might have seen the gearbox or the engine block. Engine block, the outer casing is casting. The gearbox, the outer casing is casting. That I will show you the pictures of that in the. So if you take at a production level, China is the world's largest manufacturer of castings. It is producing around 48 million tons of castings. India is producing only 12, USA 12, Japan, and so on. So the growth of the casting process is expected to be touched by 8 or 10% in 2023. Means a year later we will be at a more productions in the field of casting would be there. And just to add one more thing here, that Global Metal Casting Analysis Report 2009 shows that if we are producing 250 metric tons of casting, in global, the LFC market, this process, the casting is only around 1/4, 21 metric tons, million tons, sorry. And if you take it to the China is producing global's 50%, and out of that 50%, 19% they are producing through LFC process. So I'll show you this data that Indian market has the most uh, opportunity for. This is the lost form casting product, and this is the final product of gray cast iron. So this is a different process. So this material STMLA, this is basically uh, a beads which is being heated and is given the shape of this particular component which we have to produce. And this has been developed in India as well. Look at this. This is the first component I'm projecting here. This is the outcome of LFC process. This is a product from the casting with the foam STMA beads. This is our crankcase. Look at this, the engine block. 10-cylinder engine block is possible to make through this process. Sorry. This is differential housing. This is all tractor parts, except this engine block of 10-cylinder. Except this, all are tractor parts. So this is more important to understand that why and how we are going to improve our material efficiency, our with the help of new materials. that is lightweight. Now, aluminium is also making its presence in the tractor industry. Earlier, it was into the motor manufacturing or small casing, small engines, the motorcycle engine or scooter engine casing. Now it is also going into the manufacturing of tractor parts. This will the same way magnesium. This is enabling agility and durability. It is furthermore another component, another element which is making its way into the automotive sectors, in tractor industry, other, and another carbon fiber composites. The composites are the components of two different metals or two different items which have different characteristics, and once they are gel together with the help of adhesive or some bonding agent, they give rise to a different component which has different properties. So this way, reducing the carbon fibers, this magnesium, aluminium, lightweight, this is all we are heading toward the sustainable objectives of our industry. Redefining the manufacturing processes. When we are going to machine a lightweight component, obviously we are going to use less inserts in the machines. Uh, at this point of time, I'll just take you through uh, another one more interesting. Okay, yes. So I'm just projecting another importance of the material. Like when we are talking about the automotive industry is casting, it is also forging. So I'm taking one example from the forging side where we are putting, giving shape to the component. This is the component. This is a two-wheeler crankcase. The motorcycle or the scooter we are driving, it comes with this sort of crankcase which drives the the whole motorcycle. So to manufacture this, we produce this in the forging, this particular component in the forging process. So when we are producing, there are dies which takes the red hot piece on it and is being forced at around 1600 tons of load. You can imagine the amount of force being developed while giving the shape of these components. Because of that, the material moves, the flowability of material, the thermal cracks, the abrasion, and all these problems are coming, and that problems are giving issues for production economy. If a die produce, suppose there is a one die, it can produce 100 components and it fails at 80. So it is a loss of 20 component to the industry, to the nation, to the globe. And if this standard can produce 120 component against its set life of 100, it is a benefit for the company, organization, nation, and the globe, because it is reducing helping to reduce the carbon footprints. Everywhere you go, you will find this carbon footprint and all these things. So this is an actual experiment and actual development innovation which we have done in the industry. So what we did, we made this die and we recut the die. We recut the die and then we weld it. Look how the material is making their importance. They are more important. We selected a welding rod which can help us withstand and increase the life of that, which can withstand that 1600 force for longer times without getting deteriorated. Now, this is the analysis. So I'll tell you this all simulations. This is all simulation, and how this material will flow. This all is linked with our chemistry. How the metal at what temperature, at what force, where to restrict, how it flow, while flowing, how it will going to create the abrasion on the die, on the top face or the bottom face. All are science, all are technical which we need to simulate. We cannot build a big die and then we take a trial. So these are the things our computer engineers can come into the industry and they can help us developing these softwares, that if that amount of force with that let's say this forging process took place around 1100 14 1140 or degree centigrade, red hot, being forced with the pressure or with the force of hammer or crank or hydraulic press or screw press, servo press. A number of mechanisms are there. When we are talking about the hot forging, there are processes like cold forging, which is giving a different challenges and different uh, positive points. So when we are talking about the hot forging of this, because of the heat, you can imagine that a component on a piece of metal, this die is also a piece of metal, but it is characteristics, it can withstand more heat, more load, D12, H13, H11, H10. uh, so a die, then a hot component, which is around 1140, or sometime it is going around 1180 degrees centigrade. On top of that, a force of 1600 or some 2000 tons of force. You just imagine how it would be, what would be the scenario at that, how that scenario we have to capture. Your engineers, your scientist has to capture those scenarios to make the life easy for the industry, and this will help in reducing your carbon footprints and heading for the newer materials. Now, so what we did, we welded the die, we welded the die and we heat it, and then we did the pinning operation. Pinning operation in this material will help to make it more dense. The layer of the welding, if you hammer the welding layer, uh, it will allow you more welding to accommodate in the same volume. Then we machine it, die, and then we use it. So once, this was the initial die and this was after the trial. So we understand by just changing the material or just innovating a new method or new uh, process, new material for welding, we managed to increase the life by 11.5%. And this paper also we have published for the help of industry worldwide. So you can understand the material and their research on that material. It's very much required, and we need to understand that our preference in industry, people are required who innovate the things, innovate the materials, new materials, composite materials, smart materials, and all these are the need of the present scenario. So going back to our uh, slide, so we were discussing this why we want to go for this materials, because we need to make a sustainable stage. We need to set stage for our coming generations in the automotive fields. So more efforts are being placed on plastic. You might have seen some gear in the old vehicles. You might see the gear in the old motors, the metal or the brass gears. They now changing with the new plastic gears, some embedded plastic, and the core is the metal, outside is the plastic, which are more resistant to wear, light, can be manufactured in mass without much wastage, can be reused with very low investment. So this way we are taking industry to a next level. Bio-based materials are also making their entrance. So when we are talking about all these things, just bio-based material, natural flax, hemp, canaf, jute, all these are being used in the automakers processes to make the interior of the vehicle, to make the outer body. You might have traveled in the aeroplane. You see the interior of the aeroplane. That is not a metal. That is a composite material, and it is strong enough to withstand all sort of loads. A recycle of plastic, that is also very becoming a need of the hour. I'll go through the foundry industry, because I have currently more link with the foundry industry, where we are producing castings. So I'll show you how we are producing the castings in that, and how many sort of components, sort of item materials we are replacing, and how it has evolved to that level. We are facing a problem with the plastic, so we are just developing component which are biodegradable composites. So these things are just giving, are opening a new, altogether new industry, new market, new platform for our scientists, whether they are from any field. But our instinct, our attitude, our thought process should be toward doing research. Whatever we are doing in the automotive industry, whatever the material we are using, how we can make it better. I'll take you give one example, that when I was studying, there was a mm, they, there was a team who worked and improved the strength of mild steel by adding sand into that in a different proportion. So this is all together different perspective when we are changing from the traditional materials to the innovative materials. uh, the type of composite used in different automotives components. There are few names. Look at the carbon fiber reinforced polypropylene, how they are used in the chassis, especially in the bonnet. The glass fiber reinforced thermoplastic, they are used in front and rear seat frame, engine, noise shields, bumpers, instrument panel, brackets. So there are n number of ceramics are there. On the left side, if you see, there is slide showing that steel, aluminum, and composites. How they are different. The composites are very less in weight as compared to the steel, even less than 1/4. Thermal expansion, they are not expanding on heat or when there is a different in temperature. Their
Uh,
stiffness. Yeah.
Japesh ji, sorry to disturb you, interrupt you. Actually, your screen is not fully visible. So
Oh,
please start the slideshow. I think the
okay.
side
Okay.
slides are also coming on the
Okay.
screen.
Okay.
Yeah, now it's okay.
Sorry. So
Mm.
we were discussing the composites, a different type of components which are being used in the automotive sector. So, and their composite, look at the strength. They strength wise, they are better than steel and aluminum. Fatigue resistance, and when we are using a repetition of activity, they are better performing. The stiffness, they are better at stiff when we are putting some loads, we are loading them to the extent they are better performing over steel and aluminum. Their weight is less, their thermal expansion is less. So it means when thermal expansion is less, then these composite can be used irrespective of the geological barriers. These component, if we are using in India, same component will perform in Antarctica. The fatigue resistance, which we have discussed. Now look at other aluminum mixed composites, epoxy composites, ceramic composite. Ceramic is also a very important uh, material. It is also making its way into the machining process. I will show you one another research which we conducted. Just a moment. Yes. Uh, this is about another slide which we are projecting to show you that we have conducted uh, an experiment and we succeeded in that, and later on we published this research. We have added sulfur into cast iron Fg260. The people from the chemical industry or from chemistry by background, they might be knowing that if we sulfur is always considered as impurity in the metals, but we use sulfur and we harness different benefits from this. We increase sulfur. Normally in the market, if you see Fg216 casting, the sulfur is only in the range of 0.05 to 0.08% throughout the industry if you search. We just try to increase the percentage of sulfur. When we increase the sulfur, we also increase manganese in the proportion so that it becomes manganese sulfide. Manganese sulfide is not a metal. It is not hard. It is a powder-like material. And when sulfur combined with the manganese, it gives rise to manganese sulfide and get embedded in the metal lattice. It is not visible from the outside. When you put the metal under the microscope, you will understand that there are small flakes of graphite, like uh, similar to graphite flakes. So we did the trial, and the more important, I'll tell you, this is very important. You cannot add sulfur, a pure sulfur, which is a medicinal property, pure sulfur to metal, if because it's sublimate. This is solid, and when you heat it, it becomes gas. It is not converted into liquid. It's sublimate. So that was the major challenge for us, how to mix sulfur in the metal. So we carry out trials. We make a hearth. Being, if you see on the right side, this this is a melting furnace. This is a medicinal sulfur, pure sulfur. We can say it almost pure sulfur. So we pack this pure sulfur into a tube, which is packed at the bottom side, sealed at the bottom side, and it has a thickness of around 5 mm from all around. And we kept the top side open. Just we fixed it with a small plate without making it uh, sealing it properly, because when sulfur get heats through the walls of the metal, it will become a gas and it can explode. So to avoid that thing, we just kept it top, a, small opening. Now we put the metal, we heat it, half of the metal. This was around 500 tons, 500 kg of metal. We melt it in the liquid at around 1532 degrees centigrade, almost whitish liquid. And in that liquid, we place this capsule, and on the top, immediately within 1 minute, we covered, or we filled the balance furnace capacity with scraps or the residues of turning operation, the chips, which are quite minute. And this way we managed to we managed to mix the manganese sulfur in the uh, uh, metal Fg260. There are other ways of putting all sulfur, because iron sulfide is available, then different alloys are available which we can take and put. So this was a research that if we use the pure sulfur, how we can increase it. When you are increasing the sulfur with manganese, and then we later on we understand. So this was the complete process: raw material, storage, melting. We send the material to the heat lab. We understand that okay, the composition is correct, Fg260. carbon, manganese, sulfur, phosphorus. All these are in proportion in the range as specified. And then we pour the material. So different. The pouring process is quite different. This is a mold box. Then this is the sample, the cores, which are the inner side of the part, the part which we used for the trial. And then this part, this is called flywheel housing. This is also a tractor component. This is a casting FG260 component. So if I tell you about the composition, uh, oh no, okay, I won't be able to show you the composition here because it is a bit tricky here. So let me, then we took this component to the machine shop. You see, you have to be patient when you are doing some research or you are developing some materials. This took me around 6 months to prove that sulfur and manganese, when they are combined in a better proportion, they can reduce the machining cost. So everywhere you go, you will be having some limitation of budget, funds, and all these things. So same was the case with this research. So what we did, we made only 10 flywheel housings, and then we sent it to the same machine. We choose one machine, one operator, one fixture, and one insert, one grade of insert. And that is, insert was of ceramic insert, hexagonal. It has gone a 6 edges, ceramic tech. So that's what I was showing this, because ceramic is making its presence everywhere. Now it is also used in as an insert. So we made two trials, one without sulfur addition and one with addition of sulfur. But the life of this edge is around 200 pieces. That is a benchmark. So 200 pieces you cannot simulate with 10 pieces on a machine perspective. So what we took two different inserts and we sent it to Germany, because in India in my this one we was not be able to check the wear pattern and wear to what amount or what extent it has worn out. So they gave us top face, the different readings, that how much it has. A this is the first insert, second insert, this is the second insert, and we understand that we managed to increase tool life by 45%, and that this is a tremendous achievement. If you ask any industry, that with just increase of sulfur in a proportion of manganese, you can increase 45% life of a tool. You are making a big profit for the organizations. What is more important? Your innovative approach. You understand that this is, you cannot play with the composition of the FG260. Yes, you only play with the percentile. the percentage of the elements being used to make a final composition. So why I am showing this and how it happened, then again we research it, that those flakes, when we are machining a component, let's say we are turning it, we are rotating the component and tool is fixed and it is progressing into the component, a heat is being generated. But when you have a soft flakes inside the material, when the edge of the insert is passing over that tip, over that flakes, it is going to dissipate the heat. So the continuous heating process is being temporarily blocked over the flake. Once it's crossing the flake, again heat, then flake, dissipation of heat, again heat, dissipation, like that. It is the the life of that insert is getting increased. So this is one thing which we did in the industry. This is how we are putting efforts to develop some techniques or some materials, modify them to harness the benefits, to become competitive in the market, and also aligning ourselves with the global target of sustainability and sustainable targets. So let's go back to composites. So the next, um, uh, after composites, a natural fiber composites. These are also important because we have a pressure industry. It has a pressure on it to reduce the waste. When we are producing any component, we are also generating waste. So we have to reduce our wastage. We have to align ourselves for those components or those materials which are biodegradable, which are available in abundance in nature, on where by using those materials we are not generating a waste, or we are not generating a landfill, any sort of pollution or any sort of hazardous pollution. And these materials are workable, they can be produced. So type of natural fiber composites, their comparable application in the automotives are wood, electric component in the interior, then seat belts, sisal, hemp. The hemp is a air filter in AC. This works as a antibacterial. It kills bacteria. Coconut in the chassis, high resistance to rotten and high yield strength. Cotton seat covers, Knauf engine pulley belts, flax exterior design of the front grille, jute, abaca rain wipers. Banana leaves is also being used in electrical wire covers. Bamboo window glass paper, wheat straw headlight cover. So all these things, and all these things are natural fibers. Natural composites are being used or being increasingly getting their way into the automotive sector. So what we need to understand, how we need to show our affinity toward these composites, these natural material, how we can use and how these component or these materials are going to change my current scenario, my load of carbon footprints on this environment, how I'm going to change it, how I can use this. Somebody might have put their thoughts to use biofuel, that how a biofuel can be generated, how we are going to use, how we are going to make that biofuel. We have an abundance of sugar cane here. We have an abundance of straw, rice straw. So how we can make that? So all this is being used in the automotive sectors. This is, as I have said already, that it is also going to reduce the load of supply chain, which is more important. One more thing I uh, could not mention here in LFC process. This is a new components which we are adopting. Uh, this component, if we are producing a green sand process, if we are producing this casting, if we are producing this casting with green sand process, let's say this casting is of 100 kg. So 100 kg core to make the cavity, the inner cavities, whatever the inside, the cavities, this cavity. So we have to plug something here, so that liquid metal should not enter into that space. So to block that, we also use sand. So in green sand, we are using around 90% of sand, and that sand is if you are producing, you just take in a bigger option to, you are producing 10,000 metric ton of casting, and you are going to waste 9,000 metric ton sand. Where you are going to dump it? So this is again a issue which we have solved, or the industry is trying to solve with this LFC process, where you need not to waste any sand. Here the challenge is different. You are not wasting sand, but you are producing some gases. So that challenge is a different challenge, a bit less compared to the severity of waste sand. So when we are talking about this process, we reduce the carbon footprints, we reduce the metal, and another important thing, we can create a very minor edges, the radius, which is not possible in sand casting. So if we have to produce a component as per drawing, by default we are sending around 20%, more than 20% weight as it is in the component, because of the process inefficiency. But that 20% weight we are managed to reduce from the component, keeping the strength and everything, dimension, everything same through LFC process, means 20% of saving of metal, 20% saving of transport, 20% saving on machining, 20% you can say 20% saving on melting this metal, how we are going to produce the metal? We are going to melt it. So there are lot of efforts being carried out in the industry by the all fields, electrical, electronic is also making lot of efforts, and lot of uh, their efforts are showing encouraging results in the industry. I'll take you through the next slide.
Sir, excuse me,
Yes, sir.
Dr. This side. Sir, we should have this session till 7:30. And
Right,
after that,
sir.
we will have a break for 20 minutes. We will start another session to 7:50. So we will stop the session at 7:30, sir.
Okay, 7:30. Okay, fine. So I still have 5 minutes to go.
5 minutes. Yes, sir.
Okay,
Yes.
so let's discuss this one more important.
Okay, no problem. Okay, okay, sir.
Or you want me to discuss in the next session?
No, no, sir. You continue this slide.
Okay.
No problem.
Great.
Yes.
Thank you. So I'm just giving you one more very interesting development in the automotive sector. The magnetorheological fluids you might have studied, or you might have learned in the newspaper or in the research paper, or if you have that sort of instinct, that this is a fluid, this is only a metal, iron, which is being controlled by magnet. So once we are making this fluid, and we are using magnet or electric current to control its viscosity. When its viscosity we are changing, we can do a different scenario. You can see the earlier scenario of this spring and the fluid inside. Once this is made for only some sort of shocks. It can absorb only a specific shocks. But when we are using electrorheological fluids, where the density of the fluid, the density of the compression, or the density of that particular fluid can be controlled at your wish, you can make a different type of suspension systems. Like the same suspension system can work in the city, the same will work in the rough roads, same will work in the if you are going for excursion at the off the road.